right, welcome to part 2 of our end table series. Last time we were pretty much at the point where we needed to make a decision on how the stretchers were going to join up to our legs. And some of the options that we had were, of course, a mortise and tenon joint. Wouldn't be too difficult. A lot of ways you can make a mortise in a piece like this with either a router or using a mortising chisel and bit set on a hollow chisel mortiser. And the tenon, of course, I probably would just use a miter gauge and a dado blade on a table saw. I would say the only tricky thing about that is the fact that since these are coming up at, probably about a 10-degree angle, you're going to have to make an angled tenon on this piece. That's the only tricky business there, but even still, that's not too bad on a table saw. Far and away, the most popular option that everyone seems to want to see is the sliding dovetail. Okay, and for anyone who's not familiar, we pretty much know what dovetail joints are. They're most commonly used in drawers. But there's a sliding version where it's a very long joint like this. And another piece, which would be the male of the dovetail, slides into the female slot like so. Okay, so very strong joint, extremely resistant to pulling apart in this direction. And if you notice on this sample that I made, that goes all the way through. Okay. Now that's exactly what we don't want to do in the final piece. This was just a sample, so I wasn't worried about it. If it goes all the way through, technically, the glue is going to hold it in place, but technically this could slide all the way through and come right out the bottom. So there's nothing supporting it. So when we make our final cuts, we absolutely want to leave a little bit of material here and make what would be a stopped groove. We want to make sure that there's wood there so that we resist that downward motion as well. And between that, the dovetail itself, and some glue, that's going to be a very strong joint for this little end table. It's going to be cool, it's going to be awesome, and it's going to be a heck of a lot of fun getting that joint to fit perfectly. All right, so here's one of my leg blanks, and here's our template. Now, if you put it onto the leg blank, you could see in this region here is where we're going to need to create a stopped sliding dovetail. And the question is, how are we going to do it? Now, I know I want to use my handheld router with an edge guide to actually create that groove. But we've got solid material here. Even if we mark it out with a pencil that this is the area that that dovetail groove is going to go, how do you get the bit through the material and then start going in? So I've got a couple tricks up my sleeve on how we're going to deal with that. Should be interesting, so let's check it out. Put our template on, line it up with my fingers, and trace around with a pencil. Now the important thing here is this area right there, right where the other piece is going to join. We want to transfer those pencil marks to the edge. Extend those lines all the way across the edge. Okay. Now remember, the leg is sitting like this. We want to have it stop at a certain point. That is our dovetail groove. So I'm going to put a line at about 3/4 of an inch up from here. I think that's enough material to give us the support that we're looking for here. Draw another line, and then I want to indicate that this is not to be touched. I might even use some chalk here so that there's no question. Literally fill that in. I only want my dovetail slot to go that far, and then it stops. Okay, so now here's our challenge. We basically need to drive our bit in above this line somewhere, because this is all waste material up here. If you look at the final shape, we'll be cutting this away. But I still want to get access while this is here so that my router base can rest on this full surface and be really safe. All right, so you can't just plunge that dovetail bit down and go. I mean, you can, but it gets a little bit messy. It's a little bit scary. So I'm going to make my life a little bit easier by drilling a hole here ahead of time with a Forstner bit. I'm going to go down about 1/2 of an inch. Since my dovetail groove is only going to be about 7/16. It'll be a little bit higher than that. I'll be able to set my router down, plunge down into that open hole, and then start pulling through the material and then stop at this point. Okay, so that's the procedure that I'm going to use. All right, so check this out. We've got our router set up. I've got my dovetail bit in here. It's protruding about 7/16 of an inch, and I've got my edge guide in place. It's not set yet, and that's what we're going to focus on right now. Now, if you look closely, I don't know if you can even see it on there. We've got the black on black situation here, but what I've done is I've set my adjustable square here And I did it in a practice area just to make sure I got the right number. What I want is a channel in the middle that is about 1/2 of an inch wide. Okay, so I do a line from each side and I have a perfectly centered 1/2 inch line zone in here. That is going to be where my bit is going to travel. I want to clear all that material out. Now, in order to do that, we have to go in 2 passes. We'll put the edge guide on this side first, travel from our hole all the way to our line. Then we'll come back, switch the router around, put the edge guide on this side, and do the same pass that will just establish the far line here. So you have to do it in 2 passes. I don't even know that I'm sure there are dovetail bits that can handle that in one shot. That would have been nice, but the advantage here is I will guarantee that I have a dead centered slot by doing it once on each end and removing a little bit of material on both sides. Now, if you have a really, really deep and really wide dovetail slot that you're creating, it may not be a bad idea to chuck up a straight bit that fits well within these borders and run that straight bit through there first, and that'll clear out the bulk of the material, and then you just come back with the dovetail bit afterwards and shape it to the proper shape that you want, and that's puts a lot less stress on your router bit and your router and on you because it doesn't want to pull you in any particular direction. Now notice here, I did stay a little bit short of my line. Okay, we've got a little bit of extra material here, but I'm going to relieve that material with a chisel and clean it up that way so that I can be sure that each one is in the same spot. With the dust collection and the router bit going and everything, it's very hard to stop in exactly the right location. So a chisel and traditional hand tools are the best way to clean that up. Now the female dovetail slot is cut into all 4 of our legs. They all look pretty good, came out nice. Now, we could probably at this point turn our attention to milling the male portion on the stretcher. But just for a second, I think we should turn our attention to the center of this table. We haven't really talked about that yet. So basically, my concern here is where these joints all come together in the middle. There's going to be 4 pieces that we have to be concerned with. And how do you get 4 pieces all coming in at a 10-degree angle to meet in the middle and be secure and be a nice tight joint? So there's a lot of ways that you can do it with a big half lap. You can use some sort of complicated crossover of dowels. So I've been tossing these ideas around. I still don't 100% know what I'm going to do. I think that's going to be our challenge for next time. And any suggestions you guys have would be welcome. But one thing I am considering is the dovetail slot. Now the reason we have to think about it at this stage is because we could save ourselves a lot of trouble if that's the route that we're going to go. So I'm actually going to mill this stuff now. And even if I don't use it, at least I know it's there and ready to go. While I was milling my stock, now I've told you guys in the past, always make sure you mill extra material just so that you have it on hand. You just never know for practice cuts, things like that. You're going to find a lot of times where that's going to save you a lot of trouble. So when I milled this up, I milled up a few other pieces of scrap. So I took one of these pieces and milled it, turned it the other way and milled it to the same thickness. So now this is a perfect square representing the thickness of our stock material here. So technically, if I wanted to, if this were one of the stretchers coming in at a 10-degree angle, and let's say instead of a round centerpiece, I wanted to make mine square. Well, it's already the perfect thickness, right? So that if I were able to mill the dovetail slots in here on all 4 sides, I could potentially have a way of connecting everything in the middle and using the same material. So that's why we need to think about it now. Because if this is the same thickness, then I technically should be able to go over, put this in the bench, do the same exact routing procedure on all 4 sides, 1 pass on each side, and make the same exact size slot that we have on our legs. So if I could do that now and just have this material ready to go, it may just be a no-brainer when it's all said and done. I've got to cut the male side on one of the stretchers here. All I have to do is cut the same male on the other side, and technically, it should fit perfectly. So I've got something really cool here to show you. I just started routing the slots for the center post, the female dovetail slot, and I got through my second one, and it didn't take more than a couple inches before I was like, this is going to be a problem. They're too deep. So for a piece of this dimension, watch what happens. Those pieces, wah, 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 wah. Okay? They get awfully close to each other, leaving very little material here. So all the strength that we're trying to gain from using a dovetail is completely out the window if we do this. So what I was hoping to do was to avoid having different sized dovetails in the center and the outside, but it's unavoidable at this point. So again, this is all part of designing on the fly. That's something that I probably wouldn't have even thought of really until I got to that point. But the reason I actually had just said that this will save your butt. When you make extra material and you've got it on hand, it will definitely save you some trouble in the future. So perfect example of how that works. So I basically brought it up about 1/8 of an inch, moved it in just a little bit so it's not as wide, and this is what I wound up with. Okay? So that's reasonable, and I don't see any reason why that isn't going to work for us. So now it's time to start cutting some test pieces to see if we can get this fit right. The problem is, even if I do have a test piece, let's say something like this, there's no way to get that in there. So what I'm going to do is make a rough cut on the bandsaw and remove this top corner of material, just as if we were cutting it out for the final product. I'm just going to leave a little bit of extra material, maybe about a 1/16, and remove that.
This is one of those times when the bandsaw blade is just too wide for the curve that we want to cut. I simply do 2 straight cuts that will essentially break the curve into smaller chunks, and my blade can handle that with no problem. And I finish the cut from the other direction. Now I use a piece of scrap to set up the tools. I mark 2 lines on the end of the test piece that correspond to the bottom of the dovetail groove. I then extend those lines all the way across the end grain. Next, I want to remove the excess material in order to reduce strain on the router bit. I set the blade height so that it's well under the line. Using my miter gauge, at the proper angle, I make a few passes to remove the majority of the waste wood. Remember that the apron pieces are cut at a 10-degree angle, so we need to adjust the gauge accordingly. Next, I head to the router table where my dovetail bit is already installed. I make a few passes and make a little adjustment here and there to the bit height and the fence as I go. Once the sample fits, the machines are all set up. Now I go through the same process with my actual workpieces with one addition. I start by scribing a line around the perimeter using a marking gauge. This is pretty much going to reduce any chances of tear out.
All right, now we're making some serious progress. My stretchers both have the dovetails on them, okay? And of course, like we had discussed, the one that goes into the legs is a little bit wider and more substantial than the one that goes into the centerpiece. You can see the centerpiece has now been trimmed down to the appropriate size. And at this point, the only major thing left to do with these parts is to trim off part of the dovetail, okay? Because remember, this has to come all the way down and then sit right on top of this stopped groove here. Okay, so in order to do that, we need to remove some of this material. So hand tools is the best way that I know to get that done. Now I take it down as far as I can without actually touching the base in this area here, because we don't want to show any marks on the outside here that will really screw it up. So get down nice and close. Just like Price is Right, closest without going over. Okay, then I get the flush trim saw, And I utilize this reference surface here to saw away that material. Putting a lot of pressure down with my fingers here. And take your time here. No rush. You just want to make sure this edge is nice and crisp and even straight across. Okay, once I have a clean cut across, I can be a little bit more free with my motion here now, because that was the critical part. Now, as I'm cutting across here in this position, I'm actually going to put my finger here and bend the flexible saw up a little bit. I don't want to, to harm the integrity of that edge. So by pushing up a little bit, I can guarantee that I'm scooping out that little bit of material. Take it all the way down. Okay, let's see what we're left with here. Not bad, huh? It's pretty flush. Okay, any leftover material there? Easy enough. Just grab a chisel and pare it away. All right, now with all of the dovetails trimmed down, everything is pretty close. The thing is, there's a natural variance because we use the router to do this, and there's a lot of variables that can cause something to fit perfectly in one of these slots, but a little tight in the other. So it's best to kind of just go around to each and every one and find where the best fit is. And then once you have that, label them. Okay, so you want them to correspond to a specific socket. And that way, you can fine-tune them to fit perfectly individually. For instance, this one I labeled number 1. It slid in really nice to this particular groove here, but it didn't go down far enough. So at that point, I just grabbed my chisel and I did a little bit of work to round over this part because, straight from the saw over there, it's not round, it's square. So to really get it to seat nice and perfect and get everyone to sit in the proper position, go back to the chisel and just round over the end of this piece here and have them all fit individually. Same thing goes for the bigger dovetail on the legs. I'm going to match them up to each individual leg, number them, and then fine-tune them individually.
Fine-tuning consists of a little bit of chisel work. Be extra careful here not to change the angle of the dovetail. A quick test fit, and we're ready for the glue up. That is, if I can get this piece back out.